Here we're given helium-4 and you have this number here and this number here. Why are they so different? What do these numbers mean? In helium, this number is known as the particle mass. And what does this mean? This means here that if you add up the sum of the number of protons, in this case we have 2 protons and you have 2 neutrons in helium-4, the atomic mass unit of proton is around 1.00728 and that of neutron is around 1.00866 atomic mass unit, and you multiply them by 2 and you add the numbers together, you get this number right here. And why are we finding this number? The reason why is because based on the nuclear binding energy, the mass difference between the particle mass, in this case this here, and the actual mass of helium-4, if you look at it on the internet, is around this number, atomic mass unit. This here is kind of the isotope definitely of helium-4. Therefore, once you subtract these two numbers together, that allows us to determine what the mass difference is, which is around 0.03038 atomic mass unit. This atomic mass unit is the same thing as what in grams per mole, and this grams per mole we need to convert it to what? We need to convert it to kilogram per mole by dividing by 1,000. And why are we doing this? The reason why we're doing this is because we need to be able to get our answer of the energy later on, which is the nuclear binding energy in this particular unit. Joules nuclear binding energy is equal to the product of the mass difference and the speed of light, and the speed of light is known to be approximately 3.0 times 10 to the power of 8 meter per second. But because it is squared, we're going to apply all squared to it, multiply that by the mass difference, and once you have that in here, then we are going to be able to get our answer of the nuclear binding energy to be equal to approximately 2.73 times 10 to the power of 12. In this case, because we have kilograms, meter squared, second squared, is going to be in joules per mole. And so this here is the amount of energy that is required to hold the nucleus of helium-4 together.